Jackshan, when he jumped from the first building to the second building, the distance for the x-axis, it was 26 feet, which is 7.9248 meters, and the height, it was 15 feet, which was 4.572 meters. So at first I didn't have the time. I only had the acceleration, which is the gravity. I had the gravity, I had the delta y, I had no v naught, v initial for the y-axis. And then here I didn't have the time. I only had 0 for the gravity. I had the delta x. And so I used the delta y equal to v naught t plus half a t squared. And with it I substituted for the numbers. And I did the equation to solve for time. And after doing the full equation, I had time is equal to 0.966 seconds. So I just had seconds in both. After that, I used the second equation again to solve for the v initial on the x-axis, and I substituted the time and the acceleration was 0, so the whole equation was 0. So I had 7.9248 equal to v initial of multiplied by the time, 0.966 seconds, and the answer was 8.203 miles per second. So I had it here, and then without even doing the equation, you can tell that the v is equal to v initial, since the acceleration was equal to 0. When you have no acceleration, there is no change in value with the v initial and the v final. On the y-axis, doing the v equal to v naught plus at, I solved for v, and I had the answer as negative 8.89, and since the direction was also going down, so solving in a positive gravity, it will be a positive sign, because it's going to negative direction. And so the v final was 8.89. 8.82. And since the human can survive up to 15.5 miles per second before breaking a bone or having a big injury, making it possible for Jackshan to land safely without breaking a bone or having a huge injury.